Hello and welcome to this video on the Forbidden Experiments, Part 3, the cold moonlight lunar eclipse. Well, I guess this is one of the most forbidden experiments I've come across. To the best of my knowledge, it's neither been done by intelligent design or the non-intelligent design section, which is the creationists and the non-creationists. So it's sort of like a very taboo experiment. And on the 26th of May this year, we had a lunar eclipse and the moon happened to be the closest to the Earth, so it was a really unique situation. So I had to sort of try and catch this with some sort of experiment. Also, in addition, I wasn't sort of, I didn't wish to release the findings of this video until I'd done a full moon experiment, which was held on the which I managed to catch on the 23rd of July, also this year, which was, I tried to catch one in June, but July one was clouded over. So now both these experiments seem to be forbidden by the sort of mainstream scientific community, I guess, which is the astronomy section and NASA and any sort of teaching institute seem to have left these out. So I don't know why that is, and I've just happened to do one myself. Now, I was sort of under a bit rushed to get this experiment done, so I came up with my idea of doing it. So hopefully we can get some data from this that makes sense. Now, of course, the first one was a learning curve, and I made a few mistakes. So I've sort of, and I missed a lot of videos. I lost a lot of photos. So you might see some combined photos in this video, which was a part of this 23rd of July experiment, which confirmed a lot of my predictions. I sort of, as I said before, I held off. I made some mistakes, but I thought they were mistakes. But this 23rd of July, using just the full moon, where the sunlight wasn't involved, confirmed a lot of those findings. So quite surprising. So let's just move on to the more depth explanation. So what's this cold moonlight thing all about? It's just basically this. It's been around for a long time, possibly a few thousand years, but people report that on a full moonlit night, if you stand out in the open, you'll feel colder than someone who's under some sort of shelter. Now, this happens in summer and winter. Now, it's unusual because the logic would say that, well, you're under some sort of shelter, you'll feel warmer because you'll get radiation and you'll have sheltering from the atmosphere and that. But there's been some pretty intense experiments that have actually reduced this shelter to a very thin membrane that virtually has no radiation at all, and people still, or there's detection that this sensor or person in this situation does feel warmer. So what are the implications of this? So why even we do this measurement? So why measure energy from the moon during the lunar eclipse? Well, it gives us a really unique opportunity to analyse the energy from the sun in a different way. On the 26th of May 2021, we had a lunar eclipse here in Australia, and the moon was at the closest to the point to the Earth during that time. A very unique situation. So as we know, the sun shines on the moon, which is a great big reflector, which reflects light back onto the Earth as it goes around. Now, that all goes well, except during a lunar eclipse, when the Earth blocks the light. So the moon doesn't reflect any light back, giving us a perfect opportunity to analyse this energy more clearly, because therefore, at that point, we got no energy from the sun. So the only energy should be coming from possibly the moon itself, if it can generate energy. Or you also remember that out here there's other terrestrial bodies that could be reflecting energy as well. So it's just not the sun. So at this point we have eliminated the sun. So again, why do this experiment? Well, because it reflects and indicates a moon inconsistency. Now, there is thousands of people in this at the moment researching moon inconsistencies. So that's anything relating to the moon that doesn't make sense. Now, this is a big one because basically sunlight shines on the moon and reflects back on the Earth, so it should be warm. It shouldn't feel cold. So there's an inconsistency, needs to be investigated. So that's where we come to with this experiment. So, how do we measure this energy? So we're dealing with something new. All we know is it makes things colder. Question. It makes flesh feel colder. So from reports, a lot of people will state that it makes their flesh feel colder. So sort of not like we're thinking about a normal infrared radiation where it would make things warmer, like the sunlight. So we're possibly dealing with a new type of infrared radiation. So what do we use as the sensor? What do we use to detect this thing? Do we use a thermometer? Do we use a mercury-filled thermometer? Do we use an alcohol-filled thermometer? Do we go electronic? Do we use semiconductor sensor? Do we use microprocessor control semiconductor? What do we use? We use bimetal strip. What do we do? We don't know. So, do we use a focusing lens? Again, we don't know. So, what I came up with was, and I was really rushed to do this, I had 2 hours to knock this experiment up because I just realised it was going to happen on this day, the 26th, as I sort of come back and, whoa. I came up with a piece of aluminium, 18 mils by 38 mils by 18 mils high, and inside it is a 10k ohm negative temperature coefficient probe with a thermal paste to create the conductivity. We don't want an open circuit, this thing, thermal open circuit going in the middle of this, so I put a thermal paste as well. That goes off to one of these USB loggers, which you'll see later on in the next clip, sorry. It's the whole apparatus is mounted on 2 cheap IKEA stools, which are 400 mils off the concrete, and a block of foam. Again, you'll see this. One of the stools is into the open, exposed to the moonlight, and one will be covered. Now, I wasn't quite sure whether to use a focusing lens here or not, so I didn't know what to do. If I was going to use a lens, would I have used silicon-based, should we go on to glass or borosilicate or optical glass? I don't know. Germanium's a bit hard to get. I thought of a block of carbon may work. Diamond even, so. But as I thought more and more towards, I thought lead. Let's go right down the bottom end of the spectrum. Of the semiconductor spectrum. Let's go down to this section here, because we're thinking reverse. Let's not make this thing clear. Let's make it dark, to block. So I sort of came up with I would have liked to have honed a lead lens to focus this thing and probably put in it some sort of tube, but again I thought, whoa, we don't know what we're dealing with. Let's make this really simple. This is, as I said before, was anodized, and I didn't know whether to make that anodized or shiny. Also I only had 2 loggers, so I had to make them both dry. I would have liked to have used a wet combination as well if I had another 2 loggers. I just would have put a wet tissue over one of them to see how it would react and get a wet and dry, like a wet and dry bulb thermometer. So unfortunately I didn't have enough time, I didn't have enough hardware to do that. So the next clip will show you the setup with the two IKEA stools. Quickly before we go on to the next clip, I have to apologise for my dyslexia again. My brain, it works in two halves and they don't talk to each other. But I did say lead here, but I actually mean lead the metal. But in my head I was also thinking of an infrared LED as well. So don't rule that one out. If you do repeat this experiment, also use an infrared and IR LED detector. Again, it's semiconductor, but it's a quick way of putting a lens, and germanium plastic lens. I didn't think of, plastic will be a carbon lens, so unless you scratch the, remove the plastic off the lens, you could actually get to the germanium sensor. So as I said before, I was pretty rushed to get this experiment out, so I knocked this up in a few hours. But basically I came up with this concept of just using two USB data loggers. These are quite reasonably priced, around about $20 to $30 each. They have an internal sensor, temperature sensor, and an external probe. So I'm using external probe. Right, I'll just zoom in on that probe for you in case someone wants to make one of these things. As I said before, it's just a 10 kilo ohm negative temperature coefficient resistor, and it's mounted in this aluminium block. And of course here we've got over here is just the logger. Okay, I'll go to the whiteboard now and just give you a bit more demonstration on the setup. Okay, let's just discuss in detail the most very important part of this experiment, which is the shadow blocking mechanism. For the 26th of May, the lunar eclipse, I just used the short stand. I have two of these stands, one is short, one is tall. To create the shadow, I had a piece of plasterboard, then a layer of polystyrene, then a steel sheet. Theory being that the steel sheet would reflect any moonlight at this acute angle, allowing a gap between the sensor and the shadow mask creating device. It's quite a distance, so very little radiation would be coming up underneath and coming back onto the sensor from the concrete below. Now, during the lunar eclipse, I would bring this closer and closer towards the sensor, and therefore there was a possibility of re-radiation coming up. However, on the moon experiment, or the full moon experiment, which you'll see later in another video, I think I eliminated that error. But I didn't account for one thing in the experiment. I'm thinking conventional radiation. Now we could be dealing with a unique type of radiation that we've never come across. If we've got some sort of infrared radiation that can make things cool, this will be a very controversial experiment. A lot of people will be looking at this. A lot of people want to come back, will want to see this experiment in some sort of more detail, and they'll want to reproduce it. So it is very important. Now, for the, I lost a lot of these photos, so I had to just redo them in the lab for you to see the setup, but unfortunately on the night I lost a few of these photos. The only difference between the full moon, the lunar eclipse experiment and the full moon experiment was that the steel sheet and the polystyrene were removed, so it was just a plasterboard, which just created the shadow. So when we look at this radiation, I'm thinking infrared, it'll be reflected. However, it could be a long wave of radiation. It could be the opposite of what we're thinking. which means it could have actually come through, penetrated these layers and not be reflected and come back down and influence the sensor directly. Okay, a wild card in the pack. Again, this will be very controversial. It will change a lot of the way we think about the moon, and a lot of people are waiting for this experiment. They've been waiting for a long time. So at this stage, just have an open mind. All right, so we'll just move on to some more detail. Okay, this is the setup of my experiment, and these are the components that made it up. There was the house, the moon, a shadow mask created by a stand, the two IKEA stools with two independent sensors and going away to two independent USB loggers. Now, the timeline basically goes like this. About 1800, the moon came up full, and I mean full, it was a really bright moon. You could read by it, it was unbelievably bright. It was the closest it had been to the Earth. The moon came across, there was cloud cover originally, and I thought the experiment was over because now we had a cloud cover, it's going to influence the readings, we have a lensing effect, have a foreign body in front of the moon, the experiment's written off. Which will you encounter? This is going to happen, a very hard thing to capture. So I still ran the loggers in the hope the cloud might clear, and about 1900 the moon came over the top of the house and a crystal clear sky. Absolutely cloud had disappeared. It was unbelievably crystal clear. The whole area lit up like daylight. The experiment was extremely easy to do. There was no wind. It was just like a miracle had happened. And just before the moon cleared the top of the house, both loggers were running, and both were running identical temperatures within 0.1 of a degree of each other. So both were copying the same amount of energy, the ambient energy that was around, whether it was reflected from underneath the stool or wherever. Now, as the moon came over and closer, the shadow mask came in to effect, and the shadow blocked one of the sensors. And within a few minutes, the temperature of the blocked one that was undercover started to rise. It was almost like, okay, I didn't expect it. I really did not expect this experiment to go like that. So it went a bit longer, and sure enough, there was a clear, decisive temperature difference between the sensor that was being blocked in a shadow. Its temperature went higher, unquestionably. The moon kept coming over, and as it came over, the eclipse became more and more intense, and more of the moon got blocked, and the reading became more and more apparent that the one in the shadow was getting hotter. Everything else was identical. As the moon became closer over the top, I had to, unfortunately, move my shadow mask closer and closer towards the sensor. So now, originally there was quite a gap between the sensor, so there was no chance of reflected energy coming back here and got back onto the sensor. So that ruled out that reflected energy thoughts that you'll get by putting a shadow mask over the top of the sensor. So that didn't happen in the original first few readings, which again was I was quite amazed at that. But as the moon became more and more overhead, I had to move my shadow mask closer and closer which risks this reflected energy thing happening. Two things to watch out for when this happens in 2 years' time, if you want to do this experiment. And if you're lucky to get clear sky like I did and no wind and perfect conditions, which, hey, these things don't happen. If you ask any astronomer, this is rare. Okay, so the big mistake I made was, number one, during this period here when there's plenty of good data from the moon being blocked out, not fully blocked out, but reasonably blocked out, was I should have shifted the shadow mask from this sensor to this sensor. Now that was quite an easy task of just sliding it across. There's nothing would have changed, it's just the shadow would have changed. And I would have seen a direct comparison between the two. Mistake number one I didn't make, don't make that mistake. Number two is, this will actually shock you. Here I am working in virtually full, like daylight, so bright. Everything I'm doing, I can walk outside, I don't trip over anything, and so great. So as the moon comes over, wow, bang, it hits, that eclipse hits, it's black, pitch black, and it's quite change. You could trip over something. You can't find anything. It's just, you have, yeah. Anyway, I didn't expect that, and I virtually couldn't see the shadow anymore, where to put the shadow mask. But I still got enough data on this early period here, so I think we got enough to capture that and make the experiment sound reasonable. So get ready for next time it happens, so 2 years from now. Let's go back into more data. So before I write up those results, which you are going to find very strange, let me just quickly introduce my plane matter concept, which to me it makes sense using the plane matter concept. Quickly, what is plane matter? Okay, we just have normal positive matter as we know it on Earth today, which is our atom is based up of, if this is a hydrogen atom, we'd have a positive proton in the centre with a neutron, and a negative electron. Negative matter would be the opposite. We'd have a negative proton in the centre, neutron, and a positive electron. That would be the hydrogen equivalent. What is clean matter? Quickly, these two matters coming together. If they were to come together, they would annihilate each other, create a huge, just turn it pure energy. If they want to come together at the speed of light, so what is plain matter? It is these two energies separated by an intelligent design. Okay? Something, someone, something, or somebody has separated these two energies. And here is an example of positive plane matter, which would have positive separator and negative. Here's an example of not positive plane matter, which is negative plane matter, I guess. Negative separator, positive. Can you show me an example of this? Yes, the Earth, as I said before in that previous video. The Earth, our Earth has positive matter on the outside and negative matter on the inside, separated by this intelligent design. As I said before, our Earth is made by an intelligent design. It is a powered planet. It is not a passive rock floating around in space, travelling under the laws of perpetual motion. Right. If our Earth or another celestial body was made up of non-plane matter, which is the opposite, it would have a negative matter on the outside and positive matter on the inside. Right, the bit that we want to talk about, the electromagnetic spectrum, which is the bit that we're measuring. Okay, we have our electromagnetic spectrum looks like this. We have at the bottom end, our frequencies are very slow, long waves. We have in our MF frequency range, our radio waves, etc., TV. As we get closer and closer to the frequency gets faster and higher, and we get to visible light spectrum. Either side of the visible light we have infrared and ultraviolet, and at the far end we have gamma rays. Our electromagnetic waveform looks basically like this. We have two waves at 90 degrees to each other. We have a positive electrical wave going this way. With at right angles we have a magnetic wave. Right, so negative plane matter is totally the opposite. Our magnetic wave, the frequency are both the same. We have longitudinal waves, long frequency waves at this end. Our visible light's the same. These two occupy the same frequency in visible light. Everything's identical, except they're totally out of phase. So, in other words, our magnetic waveform is vertical, and our electrical waveform, which is now negative, is at our 90-degree path. If these two waveforms come together, they will cancel each other out if they're of equal magnitude, or they'll be a resultant depending on the amplitude of this one's higher or this one's lower. The bit we're interested in is the infrared spectrum. That's what we're measuring. This is what's coming off the moon, which is bouncing off the moon, we believe, whether it's coming from the moon, generated from the moon, or whether it's some extraterrestrial, some celestial body out there that's being reflected off. So this is the bit that I believe obviously our infrared spectrum, our IR is, we feel it, our skin, we feel things warm and it heats up. So, okay, nothing new there. But I believe the negative negative plane matter will create a cooling IR. Now, if these were two of equal amplitude, they probably would cancel each other out. The resultant will be what you'll feel. So if this one is a higher amplitude, you'll feel warmer. If this one's of a higher amplitude, you'll feel colder. Okay, quickly, that's it. Now, when I look at the data, it makes sense if I use this concept. Otherwise, to me, it doesn't make sense what's happening. So let's go and put the data up on the whiteboard now and we'll do a summary. Okay, so hopefully that explanation on the electromagnetic fields gave you a little bit more insight to the direction I'm going. Now, I did say we weren't going to use semiconductors in the experiment, and I stuck purely to passive devices to do my detection. But if we are allowed to use a semiconductor, and it does seem like we do this measurement with semiconductors, I would have chosen a Peltry module. Now, a Peltry module are these, this is actually one here, and they're about $10 from eBay. And it has a unique property of, if I was to heat one side of it with a cigarette lighter and keep the other side cool, we get a voltage. This thing would generate a voltage. And it would go through this meter, back through the ground, and if this is a voltage meter, current would flow one way. Alternatively, if I was to heat the other side of it and keep the front side cool, the voltage would swing the other way, the current would flow the other way. So that's a very good unique property that we might be able to use later on. But remember, these things are chock-a-block full of semiconductors. You know, there's just p-in junctions through these things like crazy. So another unique property of the Peltry device is if we also apply voltage to the Peltry module, we can create hot and cold depending on the direction we put the voltage or the current flows. So for example, this circuit here, I have a 12 volt supply, voltage current would flow through this switch, through the Peltry device, back down the ground, and make the front side hot and the back side cold. So we can use that as a warming device for a little refrigerator for a car fridge or something. Alternatively, if I was to throw the switch to this direction here and switch in a reverse voltage, the front side would become cold and the back side would become hot. So, a unique property we could use. Now, in our module here, by putting this aluminium block, I've actually changed the specific heat capacity of the module, right? So what I've had my sensor here, my aluminium block with the sensor inside it, going away to my logger, but this has now changed the specific heat capacity of the unit. So we can represent this by this capacitor here. So we have a little, like if electrically we've actually added a capacitor which will alter the hysteresis of the changing from hot to cold. So as I was switching the switch over, with this lag through the thermal mass of this aluminium block, we will affect the specific heat capacity of the experiment. Now, alternatively, remember I had in the experiment, I had to put this large cooking pot towards the end just to protect the experiment from the cold and the dew and the frost that was forming. So that was the equivalent of adding, say, another capacitor in the circuit, which again would increase the huge hysteresis of the experiment. So as the moon was being blocked or unblocked or whatever, the energy was changing, this would have created a huge hysteresis and the tracker may not have been able to follow it. But quite controversial, it could have, we don't know this, radiation could have gone straight through this cooking pot and had no effect. So alternatively, we can actually now use, if we want to use this Peltry module, we can actually represent it by our two energy sources. So for I think it's about 20,000 hours here in Australia, we get 2 hours, 2 hours that we can do an experiment for a lunar eclipse. So we get 2 hours out of 20,000 hours. So it's not a lot of time. So we have to, our next lunar eclipse, we have to be prepared for it. So quickly, if we were to use my concept of the plane matter, we would have something like this. The sun would reflect it off the moon, we would create this circuit here, which we see for the 20,000 hours every 2.8 years, I guess. Now, we're familiar with this. This is conventional current flow, this is conventional electricity, everything's fine. If I was to close this switch, current would flow negative through the Peltry effect module back to here, and we would have the front side either hot or cold. Well, I think hot. The front side would get hot, no problem. Now, for that 2 hours, and it's only really, of that 2 hours, it's only really 15 minutes we actually get the sun blocked. The sun is blocked by the Earth totally. So we don't get a lot of time. So what's really happening here, normally this circuit, these two switches would be closed, and the current would flow, as I said before, but over here we also have this strange energy that we don't know. It's coming from the not plane matter. Now, in not plane matter, the electron flows from positive to negative. So, if both these voltages or energy sources were the same, the current flow through, the resultant current flow through the Peltry module would be zero. However, that's very unlikely, because what we suspect is that we've really only got 1 volt to measure from the moon that we ever get this rare chance to measure. So the resultant vector of the current would be always biased to the red side. So here is my specific heat capacity with this permanent capacitor, which is this module over here. Now I put the pot over this at the last minute. So I gave up the experiment at 2200 or something like that. So to me, I was out of it because I couldn't successfully find the shadow anymore. However, I have given the data. The data is available in the Excel spreadsheets that will accompany this video. So you can make up your own mind, but at this stage the data is still inconclusive to make a judgment yet. But I would suggest next experiment we go to the Peltry modules. See if we can make up something with these. They seem to be really tuned for this sort of measuring this strange energy. So hopefully that's a bit more detail of what we can do with the... So as I said before, you get all this data on the Excel spreadsheet, but quickly here's a summary. Experiment started on roughly 16:30 on the 26th, and the loggers were turned off roughly 10:30 on the 27th, the next day. I put the loggers out at 16:30 and they ran plus or minus 0.1 of a degree within each other with both loggers. Plus there was sun and cloud, so the temperatures didn't vary that much. 1700, the sun set, again the temperatures didn't vary, plus 0.1 of a degree between the two, Celsius. 1831 is when the moon sort of was out, and I took photos, and but it was still behind the house and there was cloud cover, and that's when I said I thought the experiment was going to be aborted, but as we found out later, the sky cleared. 1935, this is the big number. This is the bit that really got my attention. The shadow just came over the top of the house, the moon came over the top of the house, and the shadow just hit the covered logger. Now, I could see the shadow come across it, and to my surprise, the temperature went from 6 to 6.1 in a few minutes. Clearly it was going up, so exactly how I thought it would go, compared to this one which was going down. The sky was absolutely crystal clear, so there was nothing in front of the moon. So this figure here was the convincing figure that when that was covered, it went hotter. There was clearly a large gap between the stands that I'd shown you earlier in those previews, and there was no, as far as I could see, no reflected energy from any other source. So there was definitely running hotter undercover. Now the next big event was this 1944 one, which was the partial eclipse starts, and you could just probably see a slight bit of colouring on the moon. 2010, 4.4 to 5, the uncovered one was running hotter, and a quarter of the moon was covered. So I could start seeing the two energies starting to influence each other. This one here was the 2018. We got 4.3 and 4.8. We had a third of the moon covered. Another significant one was when we come down here to the full moon, which 2015. Yeah, okay. It was really starting to hit here, and this figure here was certainly lower than this one. So looked like the energy from this was higher. Again, you make of it what you wish. Now, this one here was the 21-22 when I put the pots over the top of the covers, because it was the frost. The heavy frost was starting to hit, and it was damaging the dew was starting to damage the electronics on the logger, so I thought I'd just use this pot. So as far as I'm concerned, the experiment finished here. So for everyone else, if you just want to hang out for the next result after this, but I won't count the data as accurate from now on. Okay, so we'll keep this one separate from the other data. Next day, 27th the 5th, I arose at 04:53. I went outside to check the loggers. The covered logger was running at 0. The uncovered one was minus 1.3. And the moon was a full moon, crystal clear. The whole area was lit up like daylight, as I said before. Absolutely incredible daylight effect. The pot was covered in heavy frost, and the plastic cover on the other one was, as you can see in that photo, were heavy frost. I thought perhaps why this was warmer under the pot, remembering now that the Pacific heat constant would have equalised. I would assume this pot over this time, and considering the temperature, it would have actually equalised roughly to the aluminium sensor, but maybe I'm wrong. I don't know enough about thermodynamics. But for your people who are thinking above my level, which is not hard, perhaps this radiation reflected from the moon, this cold energy what we're seeing, is actually hits metal and re-radiates back to our infrared frequency. So maybe that's a wild card to think about. All right, well, thanks very much for sitting through this long video, and hopefully good luck with your experiment if you continue to go ahead with this. Thanks again.